In this question it says, or by the way, this right here, you will see this around every question. Like either it will be on the upside, or it will be down below right here, or it will be somewhere in between. This is the code of the question. This means that 9709 is the code of mathematics, which is A-level mathematics. 9709 it is subject code. By W it means winters, the session of October, November, and 2018 the year in which this question appeared in the exam. And this is the paper code, paper 1, P1, we're doing P1 right now, and this is the variant of the paper, which is 2. And the question in that paper, this was question number 10. So this is basically the question from the exam of 9709, and the exam session was winter 2018, and the exam code was P1, variant 2, in question number 10. So these all questions which we are doing in schoolx, they are from past papers. They are from actual past paper questions. Alright. So in this question it says the equation of a curve is y equals to 2x plus 12 over x, and the equation of a line is y plus x equals to k, where k is a constant. Find the set of values of k for which the line does not meet the curve. Alright, so first of all, we'll equate the equation, the equation of the line and the equation of the curve, right? And then we'll make up an expression. Then we'll try to solve that expression. Now they have asked us to find the values of k for which the curve doesn't intersect the line. So we'll solve that expression in such a manner that it has no solution. Alright? So let's carry on. Part 1. So y equals to 2x plus 12 over x is the curve. So this is actually 2x squared plus 12 over x. This is line part 1, equation 1. The other one is y plus x equals to k. So making y subtract y equals to k minus x. That's why this is equation number 2. Right? Now we'll equate 1 and 2. We'll get k minus x equals to 2x squared plus 12 over x. Alright? Now for solving this, I'll bring this x here, so I'll get kx minus x squared equals to 2x squared plus 12, and now this will become equals to 3x squared minus kx plus 12. So what we're trying to do is we're trying to find the value of x for which the sum of the whole equation is 0. Right? Now basically we're finding the root of this quadratic equation. Right? So we know that if b square minus 4ac of a quadratic equation is greater than 0, we have real roots, which means we have two solutions to the equation. If b squared minus 4ac equals to 0, that means we have a repeated root, which portrays that there is only one solution to the quadratic equation. If the quadratic equation is b squared minus 4ac component of the quadratic equation is less than 0, we have no roots, which means there is no solution to that equation. Right? Now this here is the quadratic equation, and this is a, b and c. It is basically ax squared plus bx plus c. A is 3, b is negative 2, and c is 12. Now we have to solve this equation in such a manner that it has no roots. Only then we can find the values of k for which the curve is not intersecting the line, right? If the curve happens to intersect the line, then this equation must be solvable. If the curve happens to not intersect the line, then this equation must not be solvable. And we don't know the values of k. So we'll do b squared minus 4 is less than 0, because we want to find the set of values of k for which the curve does not intersect the line, or for which this equation is not solvable. Carrying on, we get b squared minus 4ac we want to find less than 0. So b is negative k, negative 4, 3, 12 less than 0, k squared negative 144 less than 0, k squared less than 144, So it will be from positive 12 less than positive or greater than negative 12, right? Because if I draw the graph of k square equals to 144, I'll get a graph of somewhat like this. Right? So I want to find the values of k for which the value of k is less than 0. This is k. So k is less than 0 when it is between minus 12 to positive. You have already learned this in Coordinate chapter. If you cannot understand this completely, refer to the Coordinate section in the mathematics section and see the lecture videos again. Alright? Now, this is the set of values of k for which the curve happens not to intersect the x-axis. Now moving on to part 2. Before part 2, it says that in the case of k equals to 15, the curve intersects the line at point A and B. Find the coordinates of A and B. So we'll equate the line and the curve after putting the value of k as 15, and we'll find the coordinates of A and B. So the curve is k equals to 15. Curve is y equals to 2x plus 12 over x, y equals to 2x squared plus 12 over x, and the line is y equals to x minus k. Right? We'll equate these two, so we'll get x minus k equals to 2x squared plus 12 over x. Now k is 15 right here, so I'm just solving it. Right, so I'll put x here, x squared minus 15x, 2x squared plus 12. Simplifying it further, we get 0 equals to 3x squared plus 15x plus 12. Now, if we solve this, we get this must be 3x squared minus 15x plus 12. I think I made a mistake somewhere. So I did x minus k, y equals to x minus, no, y was not x minus k, y is k minus x. Right, so this will be k minus x. This will be 15 minus x. Right, and this will be, I'm going to cut this out. So this will be, if I bring this x here and multiply it by this, 15x minus x squared equals to 2x squared plus 12. Carrying this further, 3x squared negative 15x plus 12. If we solve this by using the quadratic formula or by any method which is used to solve quadratic equation, we get x1, one value of x is 4, the other value of x is 1. So when x was 4, y was k minus x, right? 15 minus x. So 15 minus 4, when x was 4, y was 11. When x was 1, y was 14. So this is 4, 11. Let's say this is point A at which the curve cuts the line. This is point B, which is 1, 14. Right? We have A and B. Now in the third part, it says find the equation of the perpendicular bisector of the line joining A and B. Alright, line joining A and B. Part 3. So now they're asking us to find the equation of the perpendicular bisector, which is the bisector of the line joining A and B. So let's draw a rough sketch. A is 411. Let's say A is right here, 411. 411, let's say this is A, 411, and B is 114. Let's say this is B, 114. Now the line which is joining these two, we need to find the equation of the perpendicular bisector of AB, right? Now perpendicular bisector will intersect the line AB at midpoint, mid of AB, right? Now to find the equation of a line, we use this formula. Now to use this formula, you need a coordinate on the line, a point on the line, which has 2 coordinates, and the gradient of the line. So gradient of the line, as this is, let's name this perpendicular bisector P. The gradient of P will be negative reciprocal of the gradient of AB, right? Now let's start by finding the gradient of AB. So gradient of AB, A was 411, B is 114. Let's take this as x1, y1, x2, y2, y2 minus y1 over x2 minus x1. y2 is 14 minus 1 over 1 minus 4. So this gives us 13 over negative 3. This is y2 minus y1, 14 minus 11. y1 is 11. So this gives us 3 over negative 3. So gradient is negative 1. Now gradient of the perpendicular bisector will be, so gradient of P is negative reciprocal of this one. Negative, multiplied by negative, then take the reciprocal, which is positive 1, right? Now we have the gradient of P. Now we need to find a point on P, and we already know that P will intersect AB at the midpoint of AB, right? So let's find the midpoint of AB, which is also the point lying on P. A was 411, B is 114. Now midpoint of AP is x1 plus x2. Let's take this x1, y1. Let's take this x2, y2, which is x1 plus x2 over 2. This is the general formula of finding the midpoint of a line. Midpoint between 2 points. So this will give us 4 plus 1 over 2 and 11 plus 14 over 2. This gets equal to 6 by 2. 5 by 2 is 2.5. This is 25 by 2, 12.5. Right? Now plugging the gradient of the equation of P, gradient of P, and the coordinate of P into the equation, y minus y1 equals to m into x minus x1. y1 is 12.5, x1 is 2.5, and m was positive 1, right? So this, if I reduce this, it's become x minus 2.5 plus 12.5. The equation gets equal to y equals to x plus 10. That's the answer to the third part.